Today we are going to learn about how to find a missing side of a right angled triangle. Can someone tell me something about the angles in a right angled triangle? Fantastic. A right angled triangle obviously has a right angle, which is always equal to 90 degrees. The first task we need to do is to understand the difference between the longer side of a right angled triangle and the two shorter sides. Discuss in twos or threes which side you think is the longest by just looking at this triangle. This side is the longest because it's opposite the right angle. Now, voting with your fingers for the next activity, you have to vote for which side you think is the longest by the end of the countdown. So for this example, we would vote with 2 fingers in the air because side number 2 is the longest. Get ready to watch the screen carefully. We are now going to watch a video about a right angled triangle. Watch it in silence and try and work out what it's showing about the different sides of this shape. Now, what I want you to do is to talk to your partner about what you think this video is showing. Hopefully you noticed that the square of the shortest sides added together is going to give you the square of the longest sides. Let's see if we can have a look at an example. If at any point during the next few examples you want to do another question, you'll find it at the bottom right of the screen. So starting with example 1, we are going to first look at the generic diagram for Pythagoras' theorem. Having a look at this square here, we know that the area of the green square is going to be a squared. By talking with your partner, can you work out why the area of this is a squared? Great, I'm sure you noticed it was the product of a times a. Can someone else tell me what the area of this square is? Great, we're going to have b squared. And last but not least, can someone tell me what the area of the red square is? Perfect, we've got c squared. So Pythagoras' theorem is the following: a squared plus b squared is equal to c squared, where a and b are always the shortest sides and c is called the longest side. We call this the hypotenuse. Can you make sure you copy down everything you can see on the screen? And have a go at starting the question if you can. We will go over the example in full once you've copied everything down. Out of the people who managed to start the question, can someone put their hand up and tell me what they did first? Yes, so hopefully you substituted the values of A and B into the equation. So we have the following. 3 squared plus 4 squared equals c squared. So we've just replaced A with 3 and B with 4. What do we do now? Amazing, so we need to start to solve the equation. We get 9, which is 3 squared, plus 16 is equal to c squared. We are then going to simplify the left-hand side of the equation, giving us 25 equals c squared. Using our knowledge of squares and square roots, can you talk to your partner as to what the next step is? Fantastic. Hopefully you noticed that what we need to do is find the inverse of a square, which is going to give us a square root. So c is going to be equal to 5. Talking to your partner again, can someone tell me what is missing from our answer? That's it. We need to make sure we put the walls either side of the equation when we're solving, and we're going to include a square root. I'm now going to give you the opportunity to copy down the end of example 1. If you are finished, please move on to example 2. Moving on to example 2 now. If you have already completed this, great work. If you haven't, just listen. You do not need to copy it down. Can someone put their hand up and remind me of what the equation is for Pythagoras? Yes, a squared plus b squared is equal to c squared. Talking with your partner, let's discuss what is the next step. That's it. So we get the following. Can someone tell me what we do on the next line of our workings? Yes, we get 36 plus 64 equals c squared. Simplifying, as before, we have 100 equals c squared, and then we can rewrite it as c squared equals 100 because we can quite easily swap the left and right hand side of the equation. Last but not least, we need to actually solve this equation, so we need to find the value of c. What do we do now? Amazing. We find the square root. So c is going to equal to 10. And as before, we need to make sure we include the walls and the proper operation on each side of the walls. As with example 1, I would like you to copy down example 3, but just the equations, not the diagram. Can someone put their hand up and tell me what is the equation for Pythagoras? Brilliant. We write this down as a squared plus b squared equals c squared. Talk with your partner for a few moments. What is different about this example? Well done. This time we are given the longest side rather than both of the shorter sides. Having a look at this equation, can you talk with your partner for a few moments about whether we could write anything other than b squared? Well done, that was a really hard question. Basically, we can interchange a and b, so it doesn't matter which of the shorter sides we label a and which of the shorter sides we label b. So we are now going to simplify the equation, giving us 25 plus b squared equals 169. But what we need to focus on is solving it in a different way. Talking with your partner, can you talk about what would be the next steps? Amazing. We need to minus 125 from both sides in order to balance the equation. So I'm going to make sure I include the walls either side, and I'm going to write down minus 25. So b squared is equal to 144. Who would be able to answer how we've got from 169 to 144? Well done. We've just subtracted 25 from 169. And then last but not least, we need to find b. So what do we do now? That's it. We find the square root of both sides, giving us the following answer. So the next steps are moving on to the worksheet. Hopefully by now you would have had a worksheet handed out 1 between 2. You need to make sure you are showing full workings as we've done with example 3. You need to make sure you don't draw the diagram, and before you start the worksheet I want to make sure that you've got the whole of example 3 copied down in your books. Off you go.